All right, this problem says when the current in one coil changes at a rate of 5.6 amps per second, an EMF of 6.3 millivolts is induced in a second nearby coil. What is the mutual inductance of the two coils? Okay, so you saw that E2, the EMF induced in the second coil, the negative sign tells it's related to the direction of the EMF. The induced EMF is such as to oppose the change that is producing it. This is the mutual inductance, is proportional to the rate of change of current in the first coil. Okay? So we are only interested in the magnitude. Okay, so M12 is magnitude EMF induced dI1 by dt. Okay. And by the way, so this is 6.3 times 10 minus 3 volts and 5.6 amperes per second. Okay, everything is in SI units. These guys, this combination of units is called a Henry. Okay, so the mutual inductance
I think she's having like reaction. Christina. Christina. Jordan, I'm gonna take. Babe, come here. You can't breathe? Okay. Should we get to the hospital then?
What's your watch on?
Her heart rate was high. She said she wasn't gonna breathe.
Should we call an ambulance?
Yeah.
You wanna go to the hospital?
Yeah, get her checked out. You look pale.
Did you?
Paul? Just with your eyes. Yeah, you look pale. Come on.
You wanna do something?
Yeah, let's just take her. Can you walk?
I can try. Jesus Christ. I'm sorry.
Mm.
You wanna get the rest of them? Thanks.
Does it happen off? Has it happened before to her?
No, I've never seen that.
So what, do you know what it is?
Allergic reaction, maybe?
All right. She said her heart rate was high.
So she can breathe.
Mm. Okay, so 1.125 millihenries. Did they take her to the hospital? All right, so a 600 turn solenoid is 0.55 meters long and 4.2 centimeters in diameter. Inside the solenoid, a small 1.1 centimeters times 1.4 centimeter single turn rectangular coil is fixed in place with its face perpendicular to the long axis of the solenoid. What is the mutual inductance of this system? Okay, so here's a solenoid, and inside the solenoid you have this coil. All right, so how does mutual inductance come in play? So this solenoid, if you change the current in the solenoid, the magnetic field it produces will change, which will induce an EMF in there. Okay, so changing currents in this coil will induce an EMF in that. And the mutual inductance is the proportionality constant. All right, so what we're going to use is Faraday's law. So this magnetic field, so the magnetic field is mu naught N I. Okay, N is the number of turns of coils in this solenoid, number of turns per unit length. So N is 600 divided by 0.55 meters. Okay, so N is 1091 per meter. Okay. So that's the magnetic field for a current I. When a current I flows in the solenoid, the magnetic field is that. So if you change the current, if you change this current, this magnetic field will change, the flux through this thing will change, and the induced EMF in this thing is, using Faraday's law, the induced EMF in coil 2 is equal to rate of change of, so magnitude of the induced EMF is rate of change of magnetic flux through that coil. And so induced EMF in coil 2 is rate of change of the magnetic field times the area of coil 2. Yeah. And so d by dt of mu naught N current in coil 1 times area 2. So induced EMF, magnitude of induced EMF is mu naught N area 2 di1 by dt. And this guy is the mutual inductance. Remember, the mutual inductance was defined like so. Okay. The sign telling you that the EMF induced is opposing the change that is producing it. di1 by dt is the current changing in coil 1, and that's the proportionality constant. So here is the current changing in coil 1, that's the induced EMF in coil 2. You see, so it depends on the configuration of all these guys. This is mu naught is a constant. N1 is the number of turns in coil 1 in the first circuit. A2 is the area of this circuit, and so on. Okay. Now, this is for this configuration. For this configuration, what if the area was like that? What would happen to this constant? This constant?
Go to 0?
0. Very good. Okay. So It depends on all those things, okay? So there's the mutual inductance. So for this configuration, the mutual inductance was mu naught N1, we'll call it N1, A2. N1 is the number of turns of coil per in for circuit 1. Okay, we'll stop here, guys. Okay. I'll see some